I'm Phil, and Merry Christmas to all my viewers, and hope you have a good time over the holiday break. In this final video, we're going to look at determining how many LEDs you can fit on your circuit. So we'll go to projects, and we were looking at Christmas lights. And in Christmas Lights, we're going to look at the final one, which is measuring current. So if you get it wrong, and particularly if you have hot lights, the old incandescent lights, it might be too hot and even cause a fire on your Christmas tree. So it's important to take safety into account. And in this video, we're going to look at how we could measure the current and hence reduce that to a minimal for your project. So let's have a look at the desktop project. We're going to use a ammeter, which is programmable. And we have two M5 stack computers. One's a fire, and it's going to power the hex arrangement of our LEDs that you can see on the top right. Okay, so if we look at some of that in detail, we'll also look at how the current changes depending on the color and the brightness that we select. So there's our project, and we'll have a look at the objective of that. So we'll just zoom up a little so you can see the detail. The objective here is that we're going to measure the total current in an LED circuit and under various LED brightness levels. And that's going to help us determine the maximum number of LEDs that can fit onto a circuit. And we'll also learn how to program and use a programmable ammeter. So the background for this is that there's a limited number of LEDs that you can fit on a circuit. And if you look at the advice, looking at the power consumption for the hex arrangement, they suggest that the current will vary up to 568 milliamps. And this is the advice that comes from M5 stack. And you also get advice from plenty of other people, including Seed Studio. So if you look at the Grove WS2813, you can see that they're providing 0.06 amps per LED on their, and that's equivalent to 3.6 amps per meter, or 18 watts per meter. So you have to take that into account when you're designing your circuits. So for this project, we've got two circuits, one for the lights, and we're going to use a M5 stack fire computer together with two Neo Hex RGB LEDs, and we used those on our previous project. For the ammeter, we're going to use a unit, which is the ammeter unit, and we're also going to use the M5 Stick C computer. For our software, we've got two programs. For the lights, here is our program, quite a simple one. And you can see right at the start, we're setting the brightness level to 10. It can go up to about 256, and we're going to increment or increase the brightness level when we press different buttons. So when we press button A, it will increase from 10 to 20. Then when we press button B, we'll go to 50. And for C, that's the maximum brightness we'll use, and that'll be 100. And if we press A and B together, it will go back to the minimum brightness of 10. And we're also showing the color on the hex array and also on the Fire computer's LCD screen. So you can see that over here. And that's our code. This is our user interface, which we paint on the screen. And overall, we got satisfactory results for that. Let's have a look at the ammeter. We're going to use the M5 Stick C computer and add the A meter unit so that we can program it. And our program is actually very simple. In the loop, we just simply measure the current and display that on the M5 stack LCD. So we might go across and have a look at the results. So we're able to determine the maximum number of LEDs after we've measured the current. And that depends on the capacity of our power supply. So if we have a 1 amp USB power supply, that may not be enough to provide power for our LEDs. So let's have a look at it. When we looked at the brightness level of 10, when we went to red, we were getting just under 100 milliamps. And same with green, but that went up for blue, just over the 100 milliamps, and 164 for when we have white, which has all the RGB LEDs illuminated. Then we increase that to 20, and it's going up. Red's going to 120. We've got blue 153, green 127, and you'll notice the white, we're going up to 258 milliamps. And as we go up in brightness, green is getting more. We're getting more for blue and up to 555 milliamps. And at the maximum brightness level, we've got green at just under 400 milliamps. Blue is over 500, 529. And you'll notice we are up to over 1 amp, or here we've got 1006 milliamps for white. So there's the maximum number of LEDs that we can pick, depends on our power supply. And we're able to determine the maximum number of LEDs in a circuit. So the issues here are safety. Don't exceed the maximum current level that your power supply can deliver. And if necessary, consider a separate supply just to power the LEDs. But the control of the LEDs can still come from your computer on a separate circuit. So overall, you can follow up the project from M5 Stack, and we might go across and have a look at that now. So we've got the ammeter, very useful use, just under $19 US, and it's currently available on the M5 Stack website. And we've also got the Fire computer. So we might go and have a look at that. And just under $50. And I'm providing the power coming via a Grove connection to the Hex lights. Stay tuned and I'll give you a desktop demonstration. In this arrangement, we're going to use the M5 stack Fire computer to drive two sets of hex LEDs, and it's the current that's driving those LEDs has been monitored by a ammeter or an A meter unit, and the result is shown on the M5 stack screen. And this arrangement is going to change the brightness of the screen. So at the moment we're 10% brightness, and if we go to the buttons, button A on the Fire, we can change that brightness to 20 from 10. So you'll notice it's gone a bit brighter, and we can have a look at what the measurements are. You can see the current's gone up. We're on white 257, green 127, and we're on blue 155, red 127, and white 257. Now we're going to increase it. We're going to B, and that gives us a brightness of 50. So we're on blue at the moment. So we just increase that. So you can see the brightness now for red is 230, and we're up to 553 for white, 227 for green, and for blue 295, red 228, and 553 for white. Now we're going to actually go to the maximum, which is 100, and we'll see what current we're drawing for that. So we're on blue, we'll go to red, and you'll notice red jumps up to 397. And for white, we're over 1 amp. For green, 395. And for white, for blue, 500. For red, and for white, we're over 1,000 milliamps. And we can reset it back to 10%. So we're now back at 10%, with blue 106, red 93, and white is 157, green 93, and blue we're back to 107.